Hey everyone, and welcome back to the Foundry by Forge College. Now, if you're joining us right after our last explainer on those rather intense backup checklists, you might be feeling just a little bit like a doomsday prepper right now. But don't worry, today we're taking a step back for a much lighter, kind of a locksmith 101 explainer. We're going to bridge the gap between those strict recovery rehearsals we talked about and the actual conceptual anatomy of what we're backing up in the first place. Think of this as getting your theoretical bearings and understanding the blueprints before we start turning any actual wrenches.
To keep things running smoothly, let's quickly look at our engineering schematics for today. We've got 6 quick sections. 1. The Great Wallet Myth. 2. Mailboxes, keys, and seals. 3. The master key pattern. 4. Comparing wallet forms. 5. Our seed phrase walkthrough. And finally, 6. Preparing for real setup. This roadmap is intentionally designed to lower your cognitive load, mapping out the exact territory you need to grasp so that when we do dive into the hands-on setup, every single click feels totally purposeful.
Okay, let's dive right in with Section 1, the Great Wallet Myth and why it's probably not what you think. Let's clear the air right out of the gate. The word wallet is honestly a terrible and highly dramatic name for this technology. When you hear wallet, you naturally think of a leather pouch holding physical coins, right? But a digital wallet doesn't actually hold any of your coins, tokens, or NFTs. Those assets live permanently and securely out there on the blockchain. So what exactly is this software we're installing? Well, a wallet is simply a manager of cryptographic keys used to produce authenticated actions. You aren't protecting digital money on your hard drive, you're protecting your exclusive ability to sign transactions. And that distinction is massive. It means the local security decisions you make on your laptop or phone have profound, direct consequences on-chain. If someone copies your keys, they instantly gain your ability to move your assets.
Moving right along to Section 2, Mailboxes, Keys, and Seals. The anatomy of digital control.
Let's see how this builds our fundamental understanding, using a perfect digital locksmith metaphor. On the left, we've got your public key. I want you to think of your blockchain address as a heavy-duty, entirely transparent mailbox out on the street. It is a visible address stamped right on the front. Literally anyone on the network can look at it, see exactly what's inside, and securely deposit letters or funds into it. But on the right side, we have the private key. This is the highly secret physical key required to actually open that mailbox. Even more accurately, it's the unique tool you use to apply a tamper-evident wax seal to any outgoing letters. Without holding that exact private key locally, you can't open the box, you can't redirect the mail, and the network will absolutely reject any transaction you try to send.
Seamlessly shifting into Section 3, the master key pattern, deterministic blueprints. I gotta tell you, across the different learning programs we host at Forge College, students constantly have their biggest aha moment right when they grasp this next concept.
And here is that brilliant piece of engineering, the HD seed phrase. HD stands for hierarchical deterministic. Now imagine having to manually back up thousands of different private keys for thousands of different transparent mailboxes. It'd be a complete nightmare. Instead, the HD seed phrase acts as a master stamp template. It's a simple, human-readable phrase, usually 12 or 24 standard dictionary words, that mathematically reproduces an infinite number of physical keys in a totally predictable sequence. This means a single seed phrase backup protects countless addresses all at once. If your computer falls in a lake, no problem. You just type this master pattern into a brand new wallet, and it predictably remanufactures every single key and wax seal you ever owned.
Let's slide into Section 4, comparing wallet forms, and evaluating those trade-offs. Because, as you might guess, not all cryptographic keychains are built the exact same way.
This smartly illustrates your structural options before you decide where to store your assets. Looking at the first row, we have the single private key wallet. Here, the keys are stored locally on your device, and a backup requires you to save a very specific, raw, alphanumeric account for every single account. It works, sure, but it's really tedious. Next is the HD wallet, which we just explored. The key material is stored locally, but one single, human-readable seed phrase recovers a virtually unlimited number of addresses. This right here is the absolute gold standard for personal custody. Finally, take a look at the custodial wallet. This is kind of like leaving your physical keys at the front desk of a bank. The service provider holds the keys on their servers. Your recovery depends entirely on their customer service department and, an email password reset. The major trade-off? You do not have true, cryptographically guaranteed on-chain control. They do.
All right, let's step into Section 5, seed phrase walkthrough, from mnemonic to identity. We're going to put on our chief engineer hats for a second and do a logical walkthrough from a simple phrase to a fully functioning on-chain identity.
We're strictly tracking the logical mechanics here so you understand what happens under the hood. Step 1 is mnemonic generation. The software uses a standardized algorithm to pull random words from a fixed dictionary. Step 2 is seed derivation. Those innocent-looking words are mathematically converted into a massive binary root seed. And a pro tip here, you can actually add a secret optional passphrase at this stage. If you do, it completely alters the mathematical derivation, meaning you need both the words and the passphrase to recover the wallet. Moving to step 3, address generation. The wallet follows specific calculation paths from that root seed to stamp out your public addresses where you can receive funds. Step 4 highlights the backup implications. You physically write down the master phrase to protect that entire derived tree of addresses. And finally, step 5, practical checks. This is exactly why you must do a dry restore. You take your written backup, load it into an isolated blank wallet, and verify that it correctly regenerates the exact same public addresses from step 3. Because if it doesn't, well, your backup is useless.
Which brings us nicely to our final section, Section 6, Preparing for Real Setup. Let's take all of this and apply the schematics.
So, the absolutely crucial point is summarized perfectly right here. Protect the private material that grants exclusive control. This conceptual foundation we just walked through is exactly why those intimidating backup checklists from our previous explainer matter so incredibly much. Remember, a wallet is literally just software. The assets, they're on the blockchain. The only thing standing between your transparent mailbox and the rest of the world is that private key. If you don't control the master pattern, the seed phrase, you don't control the physical locks, you can't stamp the wax seals, and you absolutely do not own the assets. Once you grasp this, secure backup procedures don't feel like a chore anymore. They feel like the ultimate empowerment.
So, I have to ask, are you ready to actually build your first wallet? Because you now have the exact engineering schematic to do it right. You understand the profound difference between a public mailbox and a private seal. You know why a seed phrase is a master pattern, and precisely why we rigorously test our backups with a dry restore before we ever deposit a single cent. We are going to put all of this incredible theory into action in our upcoming hands-on, step-by-step wallet creation lesson. Before you jump into that one, make sure you head over to forge.college to explore more fantastic deep dive educational resources on Web3 and blockchain fundamentals. You've got the blueprint now, but here is the ultimate question you need to ask yourself. Now that you truly own the keys to your digital identity, what will you choose to unlock first? Let's go build it.